Okay, so in this video we're going to be talking about some other kind of U-sub. If you've seen this topic before, pause the video, try the problems first. If you haven't seen this topic before, let's work through them. So what this is about, it's just we're going to be talking about a couple variants of U-sub. The thing that I'm going to talk about is when I see a function and its derivative, just like I did in the previous example video, but my derivative, for example, in number 1 right here, my derivative, I see x squared minus 9. That derivative is almost there. The derivative is 2x. I need a 2x, but I just have an x. That's what I mean. So, if I needed a 7x and I had it a 5x, if I'm only off by a constant multiple, then that's the kind of problems we're talking about. So let's talk about how to do them. So picking the U-sub, we pick our original function, not the derivative. So I'll pick x squared minus 9, and here's how you take care of it. You do the algebra just like before. Except this time, remember, we needed a 2x dx in the previous videos. We canceled those out and just made it du. But I don't have 2x dx. I have x dx. So here's how you take care of it. I take whatever I'm looking for in the integral. I just plug it in. And if I multiply by 2, I'm allowed to compensate for that if I add a 1/2. And constants being inside or outside of integrals are exactly the same, so that's something I'm allowed to do. And now I have 2x dx that I can take away. So now let me actually go through with it. I'm going to actually delete this text up here so I can make more room. So I have this integral is, I have this 1/2 still out front. You can't forget that. Integral 2x dx. Cancel, cancel is du. And 1 over x squared minus 9, u is x squared minus 9, so that's 1 over u. And that integral is one I could just do right away. And that's 1/2 ln x squared minus 9. That's it. I'll go ahead and erase this now. Let's do the second one. I see sine and cosine are my derivatives, but I have to pick which is which. My derivative has to be the one on the outside multiplied. So this is going to be the derivative, which means cosine has to be my u. Now, the derivative of cosine is negative sine, but I don't have negative sine. I have positive sine, sin, not sign. So this is just a constant multiple I'm off by, so I can just do the same thing I did before. I can throw in that negative. That's just a -1. And if I put it outside too, that's the same. So this integral is going to be negative, that's the first negative sign, negative sine x dx. Sorry, du, I forgot that dx over there. Negative sine x dx, I'm putting that in green. That's du. So I have du. And then 1 over cube root of u. So that is negative integral u to the minus a third. That's negative, I add 1/3 to the power. Negative 1/3 plus 1 is 2/3. And I divide by that new exponent. That's going to be negative, I'll throw that 2/3 into 3/2. U to the 2/3 becomes cosine x to the 2/3, because that's my u. That's my answer. I'll go ahead and sort of sector that off. Let's do the third one. Looks really disgusting, but let's just take a look at it. I notice that these polynomials are going to be what I want to do. One of those is going to be my u, but which one? Well, it's going to be the one that's inside of the secant squared, because it can't be here, because if this were the derivative, I can't take this out. That's not multiplication. The derivative of x to the fourth, let me actually write it out, minus 4x squared. What's the derivative of that? That's 4x cubed minus 8x. But I don't have 4x cubed minus 8x. I actually have this I'm off by a factor of 4. So I'm going to have to put in a 4 there. But anyway, that just helps me know what my u is. So now let's actually do it. U is the inside. Remember, it's not the derivative. It's not that. It's x to the fourth minus 4x squared. Du is 4x cubed minus 8x dx. Now, how do I put in this constant? I have to put in the 4 outside of the whole thing. And then if I put in a 4, I can throw in a quarter, because that just means I multiplied by 1. That's perfectly okay. So now I've got 4x cubed minus 8x dx. That is du. So I will just change that into integral. I've got a quarter out front. Can't forget it. Secant squared. What's inside secant squared? That's u. And then this whole thing I get rid of, and it becomes du. What's the integral of secant squared? What function's derivative is secant squared? Well, tangent's derivative is secant squared. So that's how I do it. And then I can just plug in my u. 1/4 tangent of x to the fourth minus 4x squared plus c. That's it. Now let's do the last one. Let me actually just sector this off one more time. And I'll give myself some more room. So what do I see? I'm looking for a function, and it's derivative multiplication. I see x cubed plus 2, and that derivative is 3x squared. But I have 5x squared. I mean, that's off by a constant in the middle, so that's what I can do. In this case, it may be helpful to you to just either rewrite it entirely or just think of it this way. This derivative looks like it's not being multiplied, but it really is. It's just times 1 over the square root. So I have to, let's just do the u sub. What's going to be my u? My u is the thing, not the derivative, it's the original. I've got x cubed plus 2. That's 3x squared dx. So I need 3x squared dx. I don't have that. I have 5x squared dx. So what am I going to do to change a 5 to a 3? This one's trickier. I've got to multiply that. Well, first I've got to divide it by 5. I can make it 1. And then I can multiply that by 3. And that gives me 3. If I multiply by 3/5, I'd better divide by 3/5 or multiply by 5/3. And that'll just set me up for the u sub. This one's tricky, so please rewind that if you need to. This is 5/3 integral. This is 3x squared. 3x squared dx. Take away the whole thing. Replace it with du. And what do I have left? I've got 1 over square root. 1 minus this inside is u, and I'm squaring it. What's this antiderivative? I know the derivative of arcsine is exactly that. So I know this has got to be arcsine U. Then I can just plug it back in. Put in my plus C, and that's the answer. Hope that helped.